Yeah, did you try this question? I told you to send it to me if you have done. Correct? I hope you must have tried that. Let us see the next part, that is differentiability implies continuity. Differentiability implies continuity of vector field. So here we will be starting with a differential function. We'll be applying the definition of vector field, and then we will prove that function is continuous. So let us write the statement first. Let S be a non-empty subset of Rn, and let F from S to Rm. So range set is Rm, codomain set, be a vector field and it is differentiable. If F is differentiable at E belongs to S, then F is continuous at E. Okay, this is what you are supposed to prove. So let us first write the definition of F is differentiable. Can somebody tell me? F is differentiable at A. What is the definition of that? For all epsilon positive, there exists delta 1 positive such that mod of H less than delta 1. This should imply what? Mod of C. This H, this will be mod on N, because domain is having n vectors, n values, n element. Norm of f of E plus H minus f of E minus T of H, and this norm will be norm M upon norm H n, that is less than epsilon. This is the definition of differentiability. I hope it is clear to you. Correct? Where what is T? Where T is, you can say where T is from Rn to Rm is a linear transformation. Is a linear transformation. If it is linear transformation, hence it is continuous, correct? Because we know that every linear transformation is continuous. So can I use continuous? That means for epsilon positive, can I see that there exists delta 2 positive such that norm of H, that is less than delta 2, this will imply the continuity, that is norm of T of E plus H minus T of E, and norm will be with M, that is say less than epsilon by 2, and there also I need actually epsilon by 2 only to meet. So यहाँ पे भी epsilon by 2 ही रखते हैं. Okay. Now what I need something, now let us do consideration part, then you will realize कि क्या चाहिए तुमको. What do you want to prove it is continuous? You want to consider this thing, norm of f of E plus H minus f of A, correct? This is what you are supposed to consider. So what will you do? You'll add and subtract T of H first. So it will be f of E plus H minus f of E minus T of H plus T of H. This is first thing is done. What next? Can I use triangle inequality? This will be less than equal to norm of f of e plus h minus f of e minus t of h, norm close, and plus norm of t of h. That's it. Okay, now what? Do we have a bound for this? Do you have a bound for this? Look at the first thing. I want bound for this, so this guy will be multiplied to that one. So epsilon by 2 into norm h. So this will be epsilon by 2 into norm h plus. What about norm th? What about norm th? Do you see I got from here norm of t plus e, t of e plus h minus t of a. But since t is a linear transformation, correct? So t of e plus h is same as t of e plus t of h minus t of e, correct? That is less than epsilon by 2. Correct? What do you mean by this? This is norm of t of h, that is less than epsilon by 2. So here you are having that also, you see. So this will be less than epsilon by 2. Correct? What next now I want this guy to be 1, no? So what should you choose? What should you choose your delta? Delta must be minimum of delta 1, delta 2 and 1. So one upper bound will be 1 also. That is norm h will be less than 1 also. So here that I will be using that thing. So this will be less than 1, so this will be less than epsilon by 2 plus epsilon by 2, that is epsilon. So we have proved that norm of f of e plus h minus f of a, that is less than epsilon, correct? Where what am I using here? Norm h is less than 1 I am using here, correct? Implies what? F is continuous at e belongs to s. That's it. Look at the proof once again and tell me if you see any doubt or anything. We were given f is differentiable. I wrote the definition of differentiability, and then that's it. Since every linear transformation is continuous, so t will be also continuous. So let us write the definition of t. For epsilon positive, there will exist delta 2 such that norm of h n, it is less than delta. It is better to write all the time suffix, whether it is n or m, which coordinate it is. It will be good for you. Correct? Next. Since it is linear transformation, I can apply the property of linear transformation, and that's it. Correct? Yeah. Okay. So one exercise for you, maybe you try this. Let S be open set in R2, and let f from S to Rm be differentiable at E, then there exists m positive and delta positive such that norm of x minus e, that is less than delta, it will imply norm of f of x minus f of e, that is less than equal to m into norm of x minus e. So this is what you want to prove. If you see in real case, it is as clear as you want. Since you are already given it is differentiable function, So it will be this upon this will be less than m, so this is gone there, that's it. But now the thing is, you want to do it for n variable. How will you do? Let us first quickly write the differentiability definition. F is differentiable. Do you see that here norm f of x minus f of a, that is less than equal to m into norm x? Do we have any role of epsilon here? No. So in particular you can choose for epsilon equal to 1, there exists delta positive such that norm of h that is less than delta, that will imply f of norm of f of e plus h minus f of e minus t of h and upon norm h that is less than 1. What do you mean by that? That implies norm of f of e plus h minus f of e minus t of h that is less than norm h. Now do you see अपने को क्या चाहिए? We want this norm of f of x minus f of e, that is वही जो h है. So this two part I need together and I don't want this guy. So how will you do that? First let us find what is t of h. What will be your t of h? Yes, what is your linear transformation? It will be a matrix, correct? You may think of same like you want something, some bound for this guy, na? So you may consider that only. I'll just leave one page here. You consider that and see. Consider norm of f of a. That's why it is. I told you that it is quite similar to the previous case, whatever we proved. So what will you do? You'll add and subtract t of h. Now you see what you required. You will get to know. Oh sorry, minus t of h plus norm of t of h. Okay, and you know that this guy is always less than equal to norm h, correct? And this guy I need norm of t of h, it should also be less than equal to norm h times something. That is what my claim is, because what do you want to prove? You want to prove f of e plus h minus f of a, it is m times, you want to prove this, f of e plus h minus f of a that is less than equal to m times norm h. This is what you want to suppose, you want to prove. Look at the question. At the place of e plus h they have written x, so that is okay, that is not an issue. Do you see? You want to prove m into norm x. So this is what you want to suppose to prove. So you want this guy also in terms of norm h. You want a bound for norm t of h that should give me norm h times something. So how will you do that? So let us first see what is t of h. What is your t of h? Yes, t of h is gradient vector del f1 at e, del f2 at e, and so on, del fm dot product with yes, or dot product with h, or you can multiply, you can give h to everybody, that is also okay. So this h will be multiplied to everyone, del f1 of a into h. This is like a matrix, you see that. Del fk into h, so it will be del f1 h, So this will be a vector and this will be in the first quadrant, because for this every other people will be 0, f2 f3 everybody is 0, so it will be first quadrant, so you can multiply by e1 standard vector. Same here also, del f2 at a into h, this will be only in second quadrant, so you can write it dot e2 del fm at a into h dot em. So in general you can write it as summation k equal to 1 to m del f k a dot h into ek. Correct, but what I want some bound for norm t of h, as you see, because I require norm t of h in terms of this h. Okay, so if you take norm, so this will be what? This will be norm of this whole term, that is summation k equal to 1 to m delta f k of e into h ek. Norm close. What next? If I use triangle inequality, Cauchy-Schwarz inequality, this will be, or no, triangle inequality is okay, because this is summation, no? Summation k equal to 1 to m, so it will be mod of delta fk at a into h into norm ek. But what is norm ek? That is 1. So again, if you apply the product Cauchy-Schwarz inequality, so in the next case it will be summation k equal to 1 to m, this will be norm delta fk at a into norm delta h, sorry, norm h, y delta, this will be norm h. Correct. Now do you see, you got that? You just have to norm h is there for you, you just have to take this guy inside. You have to uh, keep since it is a constant number, so you can take norm h outside. So if you take norm h outside, this will be equal to norm h into, you can say, L, where L is your this term. This is your, where L is this term. So that's it, you put it here. So it will be L into norm h. So that is, take norm h outside. So it will be 1 plus L. Put 1 plus L as m. So this is norm h into m. That's it. This is what we are supposed to prove, m equal to 1 plus L. So the main motto was to make this norm th some multiple of norm h. How did you do that? By writing what is norm t of, what is t of h, that is this, then g, this is multiplication, this is your vector, and then this can be written as summation. In the form of summation we are writing. If you want to take norm, so it will be norm triangle inequality, Cauchy-Schwarz inequality, and this is a constant, this will, you will take at this as L. So that's it. At last you just have to substitute e plus h equal to x and do the calculation. Then it will be norm of f of x minus f of e, and that will be less than equal to m into norm of x minus e. That's it. Correct? Yeah. This was the easy proof. Next thing would be, after this it was chain rule for vector field. Chain rule for vector valued function. What is chain rule? Let us write the statement first. Let f and g be vector fields. Let f and g be vector fields such that the composition that is h equal to f composite g is defined in a neighborhood of a. is defined in a neighborhood of E. Okay, suppose G is differentiable. Suppose G is differentiable at E with total derivative with total derivative G dash A, and let B equal to G of A, and assume that F is differentiable at B with total derivative F dash of B. Then H is also differentiable. H is differentiable at E, and it is given by H dash of A is equal to F dash of B into F dash of B composition or product, you can say G dash of A. That is H dash of A. That will be what is F dash of B? It is F dash of G of A, correct, into G dash of A. Write it a multiplication here. So it is F dash of G of A into G dash of A. Do you see this was the chain rule in previous case also? Correct? So in other word, if you say, or in other word, if you see, oh, actually I'm done here. I need to make a new page. In other words, if F and G are differentiable vector fields, then F composite G is also differentiable vector field, and total derivative of F composite G is given by a linear transformation obtained by composition of linear transformation. Yeah, actually there should not be a multiplication in previous case, since this is not a real we are talking about, correct? So there will be always a composition here. Here there are vectors. This is composition. Yes, composition of linear transformation of representing the total derivative of F and G. Of F and G. Correct? Proof is not in syllabus. Okay. Same if you want to see whatever we are doing differentiability in the vector field, we are relating it to matrix. Correct? So I'll give you a matrix form of chain rule. Matrix form of chain rule. So let H is equal to F composite G, where G is differentiable at E and F is differentiable at G of A, where G is differentiable at E and F is differentiable at B, which is G of A. Okay, then H is differentiable. This is the simple statement. Then H is differentiable at A. Further, if Jacobian of H of A, Jacobian of F of H, and Jacobian of G of A, F of B it should be, and Jacobian of F of yes, F of B, and next is G, no? Jacobian of G of A are the Jacobian matrix, are the Jacobian matrix of the function H, F, and G at point E, B, and E. Then Jacobian of H of E, it will be equal to Jacobian of F of B into Jacobian of G of A. This is what we are saying then. So as clear as that it is, or if you want to write, you can write composition. But for here, matrix composition is product of the matrix. Right? We'll see some example in the next class if we have some time. We can do that. And one more thing. Suppose that U is differentiable function of n variable, say x1, x2 up to xn, and each of xi is a differentiable function of m variable, say t1, t2, tm, where u is function of t, t1, t2, tm, and then this will happen, that is dou u by t, dou t1. See, u is a function of x1, x2, xm, so these are the u depends on them also, no? So dou u by dou x1 into dou x1 by dou t1 plus dou u by dou x2 into dou x2 by dou t1 plus so on. Last one will be dou u by dou xn, and this will be dou xn by dou t1. Similarly, you have to do for everybody. This is for 1. Dou u by dou t2, dou u by dou tm. There are m. So this will be dou u by dou x1, dou x1 by dou tm plus. See, this is same as chain rule. Same as what? This is same chain rule. That's it. Correct. And what next? One more. इन पर्टिकुलर अगर सिर्फ दो वेक्टर की बात किया तो वो भी चलेगा, और वी हैव डन इन जनरल, but basically let us write for two variables because we will be using all the time this only. In particular, if w is a function of xyz and each of xyz is each of, say, x is of the form x of uv, y is of the form y of uv, it is again in the form of uv, They depends on UV. Z is Z of UV. Correct? Are function of two variable UV. Then W is a function of UV and dou W by dou U क्या आएगा बोलो? Dou W by dou U. See, we can find dou W by dou X multiply by dou X by dou U plus dou W by dou Y by dou U plus dou W by dou Z by dou U. Similarly for dou W by dou V, it will be dou W by dou X by dou V plus same thing. Last term will be dou W by dou Z by dou V. Correct? And there is a diagram that is called tree diagram. See, W is a variable of three people, X, Y and Z. Now X and Y are further divided into U and V. UV, UV and UV. Now look at the first thing. If you want dou W by dou U, dou W by dou U, so you have to write all the term. Dou W by dou X into dou X by dou U. Dou W by dou Y into dou Y by dou U. Dou W by dou Z into dou Z by dou U. See? Dou W by dou X by dou U. Again, dou W by dou Y by dou U. I am taking all U together since I want to find this guy. So dou W by dou Z into dou Z by dou U. Done. So simply if you want to calculate dou W by dou B, so क्या रहेगा? You again write the same thing. It will be dou W by dou X here into dou X by dou V. Dou W by dou Y into dou Y by dou V. Dou W by dou Z into dou Z by dou V. So this is a simple tree diagram to remember this. Okay. So I'll just state a question and then maybe we'll stop. Because that will take a long time to complete. So I'll just state it and I'll left to you to try this. Say let f from R2 to R2, R2 to R2 and G from R3 to R3 be given by f of xy equal to 3x cube plus 4xy comma R3 बोलता हूँ R2 to R3 comma y square plus 3x comma x square plus y square. So this is f of x. Next g of u_v_w, that is equal to u_v_w comma u square plus, this is R3 to R2, so that I can find the composition. U square plus v square plus w square. Okay, find the following. Find Jacobian of f of xy. This is the first thing you find. Find Jacobian of g of u_v_w. Correct? And if h equal to f composite g, then also find these two people. Evaluate Jacobian of, say, g of h na. Evaluate Jacobian of h of u_v_w. Yeah, definitely it will be h of UVW, or you can say h of E for a point. Suppose E का वैल्यू हम लोग ने अगर क्वेश्चन में दे देते हैं, सपोज it is give the value of E, it will be quite easy to do then. Suppose E equal to, in the question I am telling, A equal to 1 minus 1 minus 1. So this will make our life easy. Yes. So find this Jacobian of G of A, Jacobian of H of A, Jacobian of F of G of A, and verify Jacobian of H of E, that is equal to Jacobian of F of G of E, that is verify the chain rule, Jacobian of G of A. In particularly they want to say that verify this chain rule. Find first H of E, find out karo by using composition rule and find the matrix, and this is the one method. And second, by using this Jacobian of F of A at G of A, and मतलब ये फंक्शन f का ही कंपोजिट, f का ही जैकोबियन निकालना है, where the vector will be now G of A, and next G of A, and multiply them, see whether both the things are same or not. Okay, so first thing you will say, इसको f1, इसको f2, इसको f3 बोलो, इसको g1, इसको g2 बोलो, then you should start. Solution, Jacobian of f of xy क्या आएगा? It will be simple, delta f1, delta f2, delta f3. So do that. Same Jacobian of g of UVW क्या आएगा? It will be delta g1, delta g2. Correct? Put that. So you have to find h now. H of UVW, it will be what? F composite G of UVW. That means what? F of G of UVW. Now put the values and find this. What is G of UVW, and find the function, you will get h. So in next thing you need to find Jacobian of h. So that will be what? Again same thing. Do h1, do h2, do h3. So this is the first part we are done. Correct? Now next part is at that point निकालना है, तो UVW का वैल्यू दिया है तुमको, what is that, 1 minus 1 1. So वो next part है. So try this thing, we will see in the next class. Okay, try to find the Jacobian matrix, Jacobian of this, Jacobian of this, and Jacobian of H. We'll see this question in the next class. Till that, try this, try the problem.